Cool. So, welcome all to our API Days chat. My name is Devin Tharpe. I am a solution engineer here at Gravitee, and I will be leading the demonstration portion of the call today, but I will pass it over to the main fellow that's taking care of everything, Alex Drag.
Great. Thanks everyone for joining. Today we're going to be talking about filling the API governance gap. We mainly focused on unifying API management and governance for both synchronous and asynchronous APIs. So I will go ahead and progress with the slides here. So just a quick agenda. We'll do a more in-depth speaker intro. I know Devin just introduced himself briefly, but we'll do an intro both for ourselves. Then we'll look at the governance gap. What is it? What are the challenges associated with it? What are some of the solutions? The how and why to bridge the gap. And then I know we're limited, so we'll go fast through that. And I'm going to hand it back over to Devin to actually see the solution in real life. So we'll be running a demo of a solution that you can use to bridge this governance gap. So to start, who we are. My name is Alex Drag. I am the Director of Product Marketing and a Product Specialist here at Gravitee. I live in Fort Collins, Colorado, and I have adopted all of the Colorado hobbies, whether that's mountain biking, gravel biking, gotten really into smoking meats and barbecuing, and then gardening of late. We just bought a house about a year and a half ago, so the lawn and the garden is sort of my oyster. So Devin, I'll actually hand it back over to you to do a bit of a more in-depth intro.
Again, my name is Devin. I'm a solution engineer here at Gravitee, and I take care of most of our product administrations, proof of concepts, and implementation. And anytime I'm not working at Gravitee, I'll be doing jujitsu, playing piano, or trying to be the best dog parent I can. Back over to you, Alex.
Awesome. Thanks, Devin. Great. So we will go ahead and progress in the slides here. Awesome. So welcome to Governance Gap. Now, I know the first thing you all are wondering, how in this economic climate did Gravitee manage to afford such a skilled graphic designer for these slides? My business, it's open. So if you want to get some graphic design, here I am. Just reach out to me on LinkedIn. Yes, I know that shark is it's pretty impressive. The second thing you're probably wondering is, what is governance gap? So to us at Gravitee, we see this issue in the market with our customers often where they've got sort of the REST API governance, management, security stuff kind of figured out, right? It's not so that it's easy, but there's lots of solutions and processes that have been put forward that people can put in place that make governance possible, right? So there's no gap between today and governance for REST APIs necessarily. Where the gap really appears is when you have to now manage synchronous and asynchronous APIs, right? And there are lots of risks here. Synchronous is much different. If you can't govern both, as you see with the shark, the risks really are poor quality. You might have API vulnerabilities, right? There could be issues with security. Operational efficiency becomes a huge issue. So moving slow, or maybe you release things that are buggy and then you have to roll back or release again. So it can be operationally very challenging. Like I mentioned, the quality and reliability. And then perhaps the worst part is developer experience, right? You might have this set of APIs with synchronous and asynchronous or asynchronous, and you want to give access to these to your developers internally. You might want to make it easy for them to design and create these APIs, expose them to consumers that they want to. But without proper governance in place, because of this governance gap, that developer experience can be severely impacted. So I want to run through some of the challenges really quickly, sort of what causes this gap. The first one that I want to mention is aligning standards, right? So for example, think about something like policy enforcement. This is often a standard that we see that's established amongst our customers, either team-wide or oftentimes with organizations that have done a really great job, sometimes organization-wide, right? And when you think about policies, think about things like rate limiting or quotas or threat protection or authentication, et cetera, et cetera. And what we hear often is that while we need solutions and help to do this for REST APIs, it can be done, right? There are solutions out there that can do this, that are well established and very much loved by much of the developer and architect community. But we hear people saying there really just isn't a great solution, right, in the async API world or in the event API world. So what ends up happening? You have policies that are applied to REST APIs via some sort of standard gateway solution or some whatever it might be. And on the async API part of the house, either they aren't exposed to consumers because policies can't be adequately enforced in the same way that they can be enforced for the REST APIs. Or maybe there's some separate solution that has to be acquired or built. But what ends up happening is you have this gap, right, between enforcing policies and standards around policies for REST APIs, synchronous APIs, and then these different sets of policies and or standards for asynchronous APIs. And now, why is this, right? So we mentioned there's this gap in what solutions can do. And there admittedly are many reasons, but one major reason that we've run into is that many of the gateway solutions out there, for example, they know how to apply policies to the request and response phases of communication, right? The way that these APIs talk is well understood by the gateway. But once you start getting into the asynchronous API side of the house, the event API side of the house, the message-based or the pub sub formatted side of the house, these are different ways to talk, right? And when you want to enforce policies, something like a gateway has to be able to understand how these APIs, these systems talk, and actually be able to intercept those forms of communication so that policies can be applied. And we don't see much in the market at this point that can sort of bridge that gap, that can handle both request and response and message-based pub sub form of communication. Another example of poor alignment of standards, developer portals and documentation. I mean, we hear about this all the time, whether it's just synchronous APIs, REST APIs, or asynchronous, or both, right? The dev portal documentation is something that a lot of organizations are trying to align around when it comes to their standards, right? You build an API that might be useful to many other teams, expose that in the developer portal and make sure you expose it with proper documentation so that not only can it be seen and discovered, but can actually be understood and used, right? So we do see plenty of organizations that are doing a good job of this when it comes to REST APIs. They have standards across the organization. These REST APIs that are created are put in a centralized developer portal, or maybe multiple developer portals depending on your preferences. But what about asynchronous APIs, right? We hear from people all the time who say, we've got these Kafka topics running around, or these Solace resources, these Solace event APIs. We want to be able to easily expose them to our consumers the way that we can expose our REST APIs to our consumers, right? But there just hasn't been a great central unified approach to this, right? And why? Well, one, if we take the documentation side of the house, there just aren't that many solutions that can easily generate async API documentation, right? Or dev portals that can host it, right? That's a major problem. And at the end of the day, it's because most of the developer portals out there were built for the RESTful world, right? Now, that's not necessarily a bad thing. Like, REST is everywhere, but we are seeing more of a desire and a demand to be able to expose things like asynchronous APIs, event brokers, Kafka topics, et cetera, real-time data to a larger and broader set of consumers. And the ability to align around standards as it pertains to dev portals and documentation is a major benefit if it's something you can achieve. And one of those things that if you can achieve, you can start to really bridge that governance gap. So another challenge is balancing innovation with stability. So what do I mean by this? I mentioned Kafka topics earlier, right? We hear from companies all the time, customers often, that they want to start moving towards event-driven forms of communication. I think I actually saw something from Gartner recently that said that organizations need to start adopting this event-native mindset, right? So maybe you're ready to introduce Kafka, or you want to introduce Solace or Confluent, or maybe you're an IoT, you have an IoT use case and you want to start implementing MQTT, right? And exposing those sorts of resources to folks. But this can be a problem, right? Because those folks that you want to expose this information, these APIs to, what if those consumers' applications, those client apps can only talk over REST, right? And also, if you do have standards in the org that if we're going to expose something, it has to be done securely and in a manner that is easily governable, what do you do, right? When there aren't these solutions that make that possible for things like event APIs and exposing Kafka topics, for example. So what we hear is that we have some organizations that say, well, maybe we have to make exceptions, right? Either we don't expose it at all, or we expose it without proper security or reliability measures or whatever other kinds of standards and measures that you would prefer to take. Or maybe you have to go build some other custom solution to do this for you. And once again, that sort of breaks this standard of we need things to be governed, right? It breaks that level of consistency. So that is a major challenge that we often see, that balancing innovation with stability. And if you think about things like API gateways or management solutions that are typically used for this, they become bottlenecks, right? They become bottlenecks in this process because they can't support that sort of governance and bridging that gap between synchronous and asynchronous API governance. Another challenge, and we're getting close to the end here, and I will hand it over to Devin soon, so bear with me, is ensuring compliance and security. We've sort of already alluded to this a decent amount, right, with things like policy enforcement. Maybe your gateway has authentication, rate limiting, threat protection. You're doing all that to your REST APIs. You're doing a great job there. Everything's secure. But once again, here come the event brokers. Here come WebSockets. Here come service and events, right? Here come webhook subscriptions. Are you going to be able to expose these backend resources or whatever resources or functionality you want to expose via these asynchronous forms of communication while ensuring a strict security posture and making sure that you are compliant with things like industry standards or just organizational standards, right? This becomes a real challenge for people who actually want to take this next step of exposing these kinds of resources, real-time data streams, for example, Kafka topics, to a larger set of consumers. So that's the last challenge that we're going to run through today. The solution here, and we sort of alluded to it a bit, is bridging the gap, right, with event native API management. And what do we mean by this? It's API management that is made to natively support event-driven architectures, event APIs, asynchronous forms of communication, as well as synchronous forms of communication, synchronous APIs like REST APIs. So just a quick summary here. I like to summarize everything before I hand it over to a demo. What's the problem, right, that we've discussed? As organizations start to grapple with this need to introduce and or expose, secure, et cetera, both your synchronous APIs and asynchronous APIs, governance becomes a serious challenge, right? We get that governance gap between the synchronous and asynchronous corners of the universe. Now, there is this promised land, right? If you can get there, what does it look like? It looks like operational efficiency. It looks like confidence in your security posture. Quality and reliability, excellent, right? You can push these things, expose these things, and it's not going to cause quality or reliability issues in your organization or for your customers potentially. And that developer experience rocks. Right now, if you can get past this challenge, potentially you can expose these Kafka topics and resources to any set of consumers in the org because you know you can do it securely and in a governable manner, right? And that makes all those developers that might want access to those resources very happy. Or if you're a developer who's in charge of building and exposing these things, you have the centralized, unified approach to doing so, right? So a much better dev experience there. But there are those three major challenges: aligning standards, balancing innovation with stability, and ensuring compliance and security that really can get in the way. Now we go to Devin and how we're going to get there. He's going to show you a demo of how you can use Gravitee and event native API management to unify your standards and protocols. I lost my slides there, I think, but he's going to show you all of these things. Yes, unifying your standards and protocols, how you can monitor all these forms of communication, expose your APIs and services flexibly. This is a really cool thing. We'll touch on Gravitee protocol mediation and how you can assume proper onboarding, right? Making this exposure of this data and these practices much more accessible and easy for developers in the org. So with that, Devin, I'll hand it over to you for the demo.
Lovely. Thank you, sir. All right. So I should be sharing my screen right now. There we go. Of course, the infinite mirror of everything. So how I envision us taking this demo is taking it through a couple steps. I think the first step, it's important to understand the main concepts of Gravitee, and that is just overall API creation. When we think about creating a simple REST APIs, what do we look to do? What does it encompass for us to go through the process of creating them? What policies can we begin to apply, and how simple it is to publish this onto a developer portal if we choose to. And then we move on to the asynchronous side of the house and show how we can start to align both of those workflows in a similar fashion. But to take the first step first of creating an API, you have three ways of being able to do that. But I think the one that makes sense to focus the most on today is just through the creation wizard. And so what we'll do is we'll create an Apidays API. We have version 1.0, description, as well as a context path. We're going to associate a backend or target service in which we want to use this API in front of. And then we move to the plans area. How you can think of plans as being sort of the middleman or the security layer that would actually sit on top of your API. So as we think about publishing this directly to a developer portal, potentially, this is going to be a gate that someone has to use before they are able to subscribe and use your API. And when we think of the security types that would sit in front of an API, we have a couple different options. For the sake of the demonstration, this is going to be a free plan, keyless, which means anyone that wants to come to the portal and start to curl any data from this API, they could easily do so. Let's say test here. Just because they have that ability, though, doesn't mean that they can use it as freely as they want, because we still have traffic management that could actually sit on top of this API. What I'm doing here is I'm associating a rate limit that says I want someone to have the ability to make 3 max requests over the course of 10 seconds, and then an overall quota that allows them to achieve 10 max requests over the course of an hour. I'll click next. I can associate my documentation. Here, I'll click skip and to create and start the API. So in a couple of simple clicks, we've gone through and we've created an API to be used and even applied some simple moments of traffic management directly to this API. I can make this accessible via the developer portal just by publishing it. Every deployment of Gravitee is going to come standard with a developer portal for you to access any and all information. And then another important piece is as we look to use this this API potentially, as you can see in the documentation, we have a couple different options that we can actually publish to the developer portal. ASCII doc, Async API, Swagger, as well as Markdown if we wanted to use a code editor, publish our own custom documentation. And just for the sake of showing in the demonstration, we're going to look for the credit card anomalies detection API. The reason being is because this is actually going to begin to show an async spec living within the developer portal itself. And as you can see, this is a simple example of how we would expose a Kafka topic via REST. So if someone wanted to go through that subscription workflow, they would click subscribe and now start to subscribe to this API in a governed format of having to subscribe to a specific plan, be given certain rate limits and quotas potentially, and go through the process of being approved by someone on the API management side. And just to show before we actually hop into the asynchronous demonstration, Gravitee is going to come out of the box with about 45 to 50 policies. These policies can surround overall traffic management, as we're seeing, the ability to do rate limits, quotas, but not only that, mock any data, do spike arrests, traffic shadowing. You will also have the security aspect as well. So API key, basic authentication, as well as OAuth 2 being some of the more critical ones that we see individuals use. And then data transformation. So if you wanted to do assigning specific attributes for analytics, if you wanted to do transform headers or JSON to XML, you easily drag and drop these policies onto the request and or response, as we're seeing below, to maintain and manage these APIs, as Alex kind of talked about in his slides. And the best part about this is these will also be available via the asynchronous APIs as well. But maybe we should take a look at what that would look like to actually use those asynchronous APIs. So what I'm going to do here is a transition to Postman, and I have a couple of use cases that I want to talk about today. The first one is going to be data ingestion, which is a simple HTTP post. What I'm doing here is I'm creating a new API in an automated format. With this being an API first company, I think it makes sense to kind of show how we could do all this via API as well. And this is a simple data ingestion of Kafka API. The version is going to be 1.0. The biggest thing here is you're going to see the definition version is going to be 4.0. What you're seeing here is the type of listener that we're going to be using is a simple HTTP, and the path that we're going to be consuming this on is going to be data ingestion to Kafka. We're using an HTTP post entry point, and as you can see below, I have my Kafka broker configured locally onto my machine for us to be able to accept any messages that are incoming. So I'll go ahead and send request to create the API. I'll create a keyless plan. Security is going to be important to sit on top of that API. Publish that plan, and then start my API. You'll see we get a 204 no content, which basically means everything's kind of gone through. And the first thing I want to do is go ahead and post data. So I'm going to post data once. We'll see 202 accepted, meaning everything is being accepted. So we've just sent data via HTTP post. I can't say that today. But if I go back into my instance and refresh, we'll see that those same messages that we look to stream were streamed directly to Kafka via HTTP post. And I can see the parameters, the values, the feature, Cloud 2. If I wanted to come here and change this and say, hey, this is going to be API days, I have the ability to send this one more time, and I can give it a refresh again and see that it is now there at the bottom. The next one that we'll actually begin to talk about is going to be using WebSockets. So how do I start to stream this information via WebSocket? If I were to go to my terminal right now, clear this up, and then say that I actually wanted to use WebSocket, I think it's WS localhost 8082, and then do demo /WebSockets. We give it just a second. Should give us a response saying we don't have a connection, but it might take just a minute to do that. Or we'll see that it's actually not giving us connection because of the fact that we aren't getting a response here. So what we want to begin to do actually, I'll see if I can close this out and then clear it up, is I actually want to go back to our Postman collection, which we're visualizing like so, and I want to start to create a new API. What I'm going to do here, though, is I'm actually going to create an API that has a demo WebSocket path. So we're basically creating a connection to a Kafka topic via WebSocket as we're visualizing like so. We'll see the entry point is now going to be updated to WebSocket. We have publish and subscribe configuration, which are both enabled to true. And again, our Kafka broker that is sitting ready and waiting to give us the messages that we're looking for. So I'll go ahead and click send to create this API to consume via WebSocket and go through that entire process again to start the API. And then if I go back, we give it just a minute. We should, I see what I did. I can't spell today, guys. And Alex didn't catch it for me either. I put Loa call host. So let's change that up real quick. And then in a moment, there we go. We should start to see those messages stream back for us. So we can see the parameters that we created. We can see the features in every message that we started to push back. So even if we wanted to go back into Postman, update some of the features and parameters that we're seeing here, the new parameter is going to be Gravitee is amazing. Send that back, post that information. We'll see that it's now streamed via WebSocket as well for us to now collect in the terminal here and visualize what's going on. I think the most important things that to kind of take away from this conversation, Gravitee is going to be able to facilitate these use cases not only via WebSocket, but also via SSE and webhook as well. So if you wanted to subscribe to a Kafka topic via webhook and have that information streamed via webhook, it's the same process really. And with this one, we even start to send information and you could apply policies over a subscription approval workflow or do some message filtering if we wanted to filter this message via specific metadata. So it's going to show the extent of how Gravitee can start to support those asynchronous use cases for Kafka, Solace, and QTT, and what we would be able to do for you in the asynchronous space. Being able to govern over them and apply policies similar to those REST APIs are going to be just as important, and Gravitee is taking steps to facilitate those use cases. Awesome. That is my talk. Let me stop my screen share.
Great. Thanks, Devin. Want to thank you all, of course, for joining us for this conversation. I think it was really interesting. Devin and I always love watching that demo and seeing the flexibility of the Gravitee solution. So once again, thank you all. Of course, if you have any questions or want to reach out to us, feel free to go to the Gravitee website. You can contact us, book a demo, or if you want to talk to Devin or I, we're both on LinkedIn. You can find us there. So yeah, thanks again, and we hope you have a great rest of the day.